Okay, well, here we are. So the new video for you today called Types of Functions. And some major things from our KUDs that we've looked at in terms of that relates to this video. The overall number one top selling piece of this particular one is that mathematics helps to reveal patterns. That's our whole big underlying thing of the actual whole district-wide curriculum is mathematics helps to reveal patterns. And functions, which we've been talking about, follow patterns that are recognizable in graphs, equations, and tables. And we want to be able to identify different functions based upon their graph, their table, and their equation. So that's what this video will help us do. It builds on the work we've been doing. You see it's 22 pages, but it's not that bad. So I'm borrowing a little bit something from the Global English with GPEC, and we're going to call it GETS. And for GETS, what we want to worry about is we want to look at a graph. We want to look at the equation. Magic. We want to look at a table. We also want to be able to look at a story. And from any of those things, from the graph, the equation, the table, or the story, we should be able to get at what type of function it is. So GETS just as a way to remember that we can always look at a graph, an equation, a table, or a story. Okay? Let's see, a little bit of a terminology piece that we want to get handled, get under our belt. When we have any kind of expression like this, okay, a times x to the nth power, just word-wise, we call this a coefficient. It's just a number that's in front of our, it's acting very weirdly today, coefficient, yeah, that's right. Okay, so any kind of number that's multiplied, so if I had like 3, that's a coefficient. Anytime we have a letter like this, it's called a variable. Okay, like x, sometimes it's y. Typically variables are towards the end of the alphabet for some reason. And then this, when it's written this way, is an exponent. It's awful. 3x to the 5th power. Coefficient, variable, exponent, just so we're aware of the notation. So what we want to look at for every one of these functions, these types of functions, we want to look at what the graph looks like. We want to look at what the equation looks like. We want to look at what the function, what the table looks like, and we want to talk about what a story would look like for any of these. So linear function, the key that hopefully is jumping out of you, the key part of that word is line. Okay, it's a line. So when you look at a graph and you see a straight line, it's a linear function. And it's a function because it'll pass that vertical line test and all that sort of thing. So pretty obvious, look at a graph, it's a line, it's a linear function. When we look at an equation of a linear function, they typically take a form like this. So 3 times x to some number, so it's typically some number times x plus minus some other number. But the key is that x is just to the first power. There's just an x. There's no bigger thing going on with the x. And when we look at the table of values for a linear function, and this table matches up with that graph, what we notice is that every time we move along from one number to the next, to get from here to there, we add 3. To get from here to there, we add 3. To get from in between, which I didn't put in, we add 3. So every time we add or subtract a constant number to get from one number to the next number. Acting bizarrely. All right, so that's the thing that we'll notice the pattern in the table is that we jump by the same amount. So it's not always 3, it could be 5, 7, it could be -2, whatever it is. But it's a consistent jump that we can recognize. As long as these numbers are consistent on this side, we'll get a consistent jump on that side. Okay, so if these jump by 1, we'll get the same number. If they jump by, you know, if I have a table with 1s, 4, 7, 9, or whatever, on the x side, wouldn't be quite the same. Okay, so in terms of a story associated with a linear function, the stories take a basic form. Okay, you have blank, whatever it is. Okay, you get blank each whatever. I'm going to say day. That's blank. Okay, you get blank. So this is some number. You have so many of whatever it is, and you get a certain number every day. And then the question will ask, so how much? So the idea is that you're getting the same amount of whatever it is, and you start maybe with something. So you have 5 baseballs, and every year when you go on vacation, you get 2 baseballs. So after 5 years of vacation, how many baseballs are you going to have? So it's that consistent, you're always getting the same amount of whatever it is on a regular basis, and we want to know how much you have after a while. Okay, so in terms of a graph, an equation, a table, and a story, that's what a linear function looks like. Okay, and if you remember when we were outside, we did some linear functions. This, I think, is the one where we added 2 from our number or something like that, and you can picture sort of a straight line. You guys were not exactly in the straight line mode, or we might have caught you mid-snap, but the folks with the signs here, that should be, I think, a straight line. I'm not sure. I think that was the linear function. These guys certainly appear to be in a straight line, and I think maybe these are not. I don't know. It's an odd one, but I think that was the point of that one. On to an exponential function. Okay, the easiest way to tell an exponential function is to start with the equation. Okay, see where my variable is? My variable is right there in the exponent stop. Okay, so my variable in an exponential equation, hard time spelling, writing, my variable is an exponent. Holding this differently when I'm doing it. Something seems amiss or delayed. So an exponential function, the variable is the exponent. That's the giveaway. See the x up here? It's an exponent. That tells me probably an exponential function. When I look at the graph stays above the x-axis the whole time. I wonder if I can make that a little bigger. Let's see if I can make this graph bigger for you so you can see. I don't know if it really helps much. But if I was able to trace along this graph, I think I want a different colored pen. Just because that black pen is not really working that well. Blue, there we go. So if I traced along this one, this line would just continue along here. It would never quite get to 0, and so we're always up above here. It crosses the x-axis most of the time at 1. Okay, if it's just a straight like this, this one's going to cross at 1. And it gets big really, really fast. Okay, that's what tells me the exponential function. That's kind of the key features. It gets kind of really tight to the y-axis here. The y-axis, oh sorry, tight to the x-axis, I misspoke. Tight to the x-axis here, and then we go through at 1, and then we get really, 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 really big, really, really fast, okay? At the table, to get from one number to the next number, instead of adding, if I added, I'd be adding 2 here and then 6 there. To get here, I'm going to multiply. I multiply by 3. I, again, multiply by 3. I multiply by 3. I multiply by 3. The whole way down to get any one of these numbers in the table. Okay, so we end up with some sort of constant, repeated multiplication. It's annoying me. Repeated multiplication. My writing's bad, but this is making it worse. Multiplication. So, constant repeated multiplication is what we're looking at. In terms of a story, for this particular one, the story goes like this. We have, or you have, or somebody has, your dog, your uncle, blank, okay? You get some number times as many. Get this many times as many, and then the question is how many is. So sometimes the words that we look for are like doubles, triples. So you have, I don't know, 2 pieces of bubble gum, and every day you get twice as many as you had the day before, or you have money in the bank, and the bank for some reason is giving you triple the amount every time, or something along those lines. So it's kind of like you have a certain amount, but the way you're getting is double the amount every time. It's that constant repeated multiplication. That's the story for the story form for these. Okay, and if you remember on this particular one, we've got right here passing right at 1, and then going up really, really quickly. You can see somebody up there. Yeah, hold on for 1 sec. All right, so that was Mrs. Cole checking in with me. But meanwhile, what you want to be aware, what you want to remember, because we had somebody way up there. You can barely see them, but things were jumping way long away from this as we were moving along through this. All right, quadratic function. Okay, graph-wise, easiest to tell. It looks like a U. It's got that U-shaped thing going on, so we know that that's what makes a parabola. That's what it's called, is a parabola, quadratic function. That's the thing that's going to give you away when we're looking at an equation. If it's got squared and nothing bigger than squared, it's going to be a quadratic function. That's the vertical line test. Okay, on the table, you're going to see some sort of pattern where we're going to go down and then we're going to go back up or something along those lines. If you notice, like the jump-wise here, it's going by down 5, and then it's going down 3, and then it's going down 1, and then it's going up 1. Okay, and then it's going up 3, and then it's going up 5. But if you look at the difference between the jumps, the difference between those is always, in this case, 2. So we get that consistent jump 2 layers out. That tells me we've got a quadratic formula. So we've got that symmetry where it's kind of, going up and down, and we've got the second degree of separation, if you will. Quadratic stories usually have to do with things falling or flights through the air, anything like that. Falling or flight, or it's crazy when I can't see what I'm writing, but it sort of looks okay. Okay, those are the sort of stories that deal with it because gravity does things with a parabola. Okay, any ball going through the air is a quadratic function. Okay, if you're missing your free throws, adjust your quadratic function and you'll shoot better. Okay, this is our parabola that we did outside. We had kind of that U-shaped thing going on. We had a couple people up there. Camera angle's not great. Next year we're renting a cherry picker. Okay, absolute value function. Graph. It's a V. That's the easy way to tell. The graph of the V tells me that. The equation's got these little things right down here, which mean the absolute value. Okay, absolute value. That's what those little bars mean. That means take whatever's inside the little brackets and make it positive because it's distance. On your calculator notes it with this abs x thing. Table, you're going to see what looks like a linear pattern, but at some point it's going to reverse. Okay, so it looks like we're going down 1, down 1, down 1, down 1, and then it goes up, 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 up. Okay, all our numbers turn out to be positive in this case because of the graph, but we've got that sort of symmetry place where suddenly we turn around and start going in the other direction. We go down, then we go back up. Okay, 2 linear things all together. V-shape, absolute value function. Story on the absolute value function. I don't know, probably anything to do with distance. So if we're talking about how far you are from home or how far you are from the earth or something like that, might be an absolute value sort of deal. So when we talk about distance traveled, okay, distance or displacement, that's an absolute value story. All right, there we were, making an absolute values function. We had that, we had that. Remember I asked you how far you were from 0? That was the absolute value function. Moving on, step function. Easy to tell. Graph looks like a step. I had a little person standing over here. Okay, there they are. They could just climb up the steps. Step, step, step. That's why we call it a step function, because it looks like steps. The equations are going to be pretty much, like some number. So between -3 and -1, it's 3 right there. Between -1 and +4, it's at 5. Anytime bigger than 4, we're at 7. So we just continue along. We make little steps. We have nice, usually horizontal lines. So these parts are usually numbers. And you can see the steps happening in the table. Steps happen in the table. Boom, 3 for a little while, then 5 for a little while or longer, and then 7 from there on in. Any number after here would be 7. 7, 7, 7, 7, 7, 7, 7, 7. We made a step function when we were outside. Had a step here, had a step there, we had another step there, and we had a step there. All steps right there, broken apart. Not a nice continuous thing, but a function nonetheless. Piecewise. Piecewise, we got just a couple of rules going on, is what happens. So, the graph may look all weird. We've got part linear, we've got part that's got a little curve to it. I don't know if you can tell it there, but we've got part that's a linear function, part that's a parabola in this one. We could have things going up and things going down. We could have all kinds of different things going on. We have different rules. When you have an equation, the equations are typically going to be more than one equation. Okay, sort of like my piecewise or my step function was. I had a bunch of different rules. These ones turn out to be some sort of rules with linear functions or quadratic functions. Tells us when this one works for x less than 2, this one works for x greater than 2. Okay? So multiple equations would probably be the thing that's going to tell you that we have a piecewise thing going on. Equations. Got it. All right. It's going to show up, I swear. All right, don't know what that is. And then in this, when we're looking at a table of values, we get table of values there for the linear, plus 3, plus 3, plus 3. And then we get a different table of values here, different pattern. This one turns out to be a quadratic. When you're on your calculator, the first rule only works till there. These sort of don't make any sense. And the second rule doesn't start working until there. So your table of values, you're going to have a couple different patterns showing up in your table of values. We made a piecewise function. I don't know if you can see it, but we had like a linear thing going on here, then we had a dot there, and then we had a downward linear thing going on here. Okay, so we had 3 different pieces, 3 different rules going on, and that's what we're saying. Okay, so now you want to know what type of function. I'm going to show you some pictures. You're going to fill in what type it is, or I'm going to either show you a graph, an equation, a table, or tell you a story, and then you're going to write down the type, and how do you know? So just sort of summarize what it is that we've been doing here. So problem number 1. I'm going to go probably relatively quickly because you can pause. Okay, so looking at it, it's an equation, right? So is that what type of function that we've talked about so far? Write that down. Pause if you need the time to. Story number 2, or table. This is the table. It's not a story. Example number 2. What type is it? How do you know? Write that down in where number 2 is. Number 3, a little story about Icky. Once upon a time, Icky had 7 dimes. One day, his uncle Festus gave him 2 dimes. If he does not spend any of the money, how many dimes will he have after 6 days? Okay, so this is a story, and you need to tell me what kind of story it's going to relate back to. What type of function do we have of the choices that we've talked about so far? And we have another table, and we've got a table of values. Look at the table of values. Tell me what sort of function you think we have going on here. Okay, moving fast so you can pause. And finally, got a graph for you. Graph, tell me what type of function that graph represents based on the type that we've been talking about. Okay, so that's it. So we were looking at graphs, we looked at equations, we looked at tables, we looked at stories, and we've got ourselves some functions, different types of functions that we've been playing with and we'll continue to play with as we work our way through. So hopefully this made some sense. If it doesn't, well, you ask some questions tomorrow, and we'll see you there. Hope you learned something. Went a little bit over, but I think you can deal with it. Thanks for watching. Talk to you soon.